Well, good morning, everybody, and welcome to the Dahua webinar. My name is Simon Nash, and I'm presenting to you live from our headquarters in a rainy, very rainy Maidenhead this morning. So a warm welcome to you despite the weather. It's my pleasure today to be able to talk to you during our fire alarm, which I apologize for setting a new standard in Analogue HD. Our fire alarm works, and also to talk not only about Analogue HDs, but also thermal camera technology, which features the latest artificial intelligence, or AI. In terms of the subjects that we're going to be covering this morning, would like to start by giving you a little bit of an introduction towards thermal camera technology, and then really talk about how artificial intelligence is setting new standards with Analogue HD. As you will know, many of you will know, a lot of customers still have a very large existing infrastructure of analog coaxial cable. And it's not always necessary and not always cost effective to be able to want to remove all of that to install new cameras with the latest technology. So our Analogue over HD, or HD CVI technology, as we call it, really gives you the opportunity to share with your customers the latest technology across an analog infrastructure. And then we'll look at hopefully why, if you're not currently using Dahua, why you'd consider using us, and more importantly, if you want to use us or you are using us, where you can buy our products, services, and solutions. We have a Q&A session as well. So if you have a question, the audio doesn't work very well. Two-way audio doesn't work too well during a webinar. So therefore, we have the chat feature of the webinar, GoToWebinar. So please send the question in. We have a team of people here in another part of the office, all ready and waiting to take your questions. And at the end is a new feature for webinars from Dahua during 2021. We're having a fun quiz at the end. So let's take a look at that. What you need to do is to download the Kahoot app. A lot of you will be familiar with this already. So download the app during the webinar, and then you can play along, and you can win a luxury hamper at the end of the day. So the quiz will be at the end of the webinar. All the questions in the quiz are multiple choice. It's a fun quiz. You take it or you don't take it. It's entirely up to you. But you do stand the chance, and you can see your ranking on the scorecard to see how you're doing compared to other players. So it's completely anonymous, and you can play along. But if you enter your details correctly and win, then you stand the chance of winning the luxury hamper, and we're giving away one per webinar. So good luck with that. Let's make a start by looking at thermal camera technology featuring artificial intelligence. And I'd like to start by giving you a bit of an insight into the thermal market, because this is a really important area. And thermal cameras have been around for decades now, but they've tended to be very much the use has been military, high-end military, and high-end commercial. But as you'll see during the introduction, the price point has dropped and dropped and dropped. And there's a number of reasons for that that we'll discuss in the next few minutes. So we'll talk a little bit about the market insight to start, and then we'll look at the introduction of our thermal solution a little bit later. So to start with, it's sometimes useful to look at a few thermal principles. And it goes without saying that thermal technology, any object above absolute zero, which is minus 273 degrees centigrade, emits infrared radiation. and if you want to know where that sits in the spectrum, you can see here that the visible cameras sit and work in the visible range, and thermal cameras present pictures of long wave in the long wave IR spectrum. So essentially, what a thermal camera does is to give us a visual representation of the thermal world. So if a camera was looking at me today, I've got a lot of lights around me, so I'd be probably very hot today. And compared to maybe if I was outside, I'd be cooler or warmer compared to the background, but overall cooler. So the thermal camera gives a representation of thermal the thermal mass of different objects. So it's translating, if you like, thermal temperature readings into visual information. And of course, we can use that during processing of the information, but also for surveillance and security applications. But how does the camera work? Well, here's a simplified view of what a thermal camera looks like. Over here, we have a target that the camera is looking at. The first difference between a thermal camera and a visible camera or a conventional camera is the type of lens that we use. The camera uses thermal cameras use a lens made of germanium, which is a naturally occurring substance found in the earth, and it's mined and it's milled to different shapes and specification. But it is very, very expensive, and that is one of the contributory factors that makes thermal cameras a little more expensive, certainly when compared to conventional visible cameras. The unique feature of a germanium lens is that it will allow infrared light to pass directly through it, whereas it won't allow visible light or ultraviolet light to pass through. So it's a blocker to visible light and ultraviolet light. And that, you know, can be a limitation, but it can also be a huge benefit, as you'll see later in the webinar. So the camera's pointing at a subject. We've got the lens, and the purpose of the lens is to focus the energy onto the detector. And sometimes this is called a focal plane array. Essentially, it's a detector. It detects the thermal energy that's been focused on it by the lens, and it will convert that to electrical signals. So if you like, it's almost like a transducer. So it converts from thermal energy into electrical signals, and those are processed in the signal processing section, and then we apply all sorts of algorithms and image processing techniques to that information. And the output of the camera, whether it be an analog output or an IP output, is a thermal image. And therefore, you can see on the right-hand side, that image is a thermal representation of what the camera is looking at in the target view. Now, just going back to the detector itself, they come in a variety of different resolutions and pixel pitch, and these are the trends, if you like, the latest trends in the industry that we'll be looking at a little bit later in the webinar. So we've looked at how a camera works and what it looks like in basic form. Let's have a look at the market, because we've got to have a market to be able to sell these cameras into. And the market, the global market, is over $4.6 billion, or estimated to be over $4.6 billion in 2022. It's a very big market. And the commercial area of that, including surveillance, accounts for over 70% of that. And as you'll probably be familiar with the global epidemic, there's been a lot more requirement for people to measure temperature, whether that be with a handheld device or whether it be with one of our TMAC or body temperature monitoring solutions. There's a requirement to measure the temperature of people as they enter into or leave a building. So the epidemic has certainly fueled the growth of these cameras. But even without the epidemic, the market growth is estimated to be very large. So there's a good degree of growth for us to take advantage of, not just in terms of security and surveillance, but also monitoring, inspection, and detection and measurement. So when we come to look at the different areas or the different applications of thermal technology, we will consider those three areas, because we have, as you would expect, a product offering in all of those. One of the trends of the industry, and it has been for a very long time, is something called wafer level packaging, and this relates to the way a detector is produced. So we want to get the detector as small as possible. Of course, that comes with downsides relating to sensitivity, but we can counter that in other areas. But essentially, wafer level packaging is a manufacturing technique that is enabling lower detectors to be produced at lower cost with higher specification. So it's very much an enabler to smaller and smaller devices. And of course, if they're smaller, they need less germanium, and therefore the price comes down, and it makes it more affordable for traditional security applications. One of the other trends is relating to pixel pitch, And there's been this general trend over the last sort of 10 years or so to get a smaller and smaller pixel. The smaller pixels change the sensitivity, but they also change the size. And if they change the size, then the cost is down as well, because you need less germanium and less of the actual product itself. So because the detector chip is smaller, it is also enabling it to fit into smaller cameras. We can fit detectors now, as you can see, they're very, very small. They can be fitted into a very small form factor. You know, and we have some fusion cameras, we call them, which is a visible camera and a thermal camera in the same package, and it's the same size as a bullet camera or a turret camera, as you'll see later. So the size and the wafer level packaging are big contributing factors to a cost down. So what I've done in this slide really is to give you some idea, and these are not based on any one specific manufacturer. These are average selling prices for thermal cameras going back over the last 4 or 5 years. So if you go back just 5 years to 2016, the average selling price of a thermal camera or a camera featuring thermal technology was around about £2,000. And if you contrast that to the same sort of camera, although today it would have a lot more features and benefits compared to 5 years ago with things like artificial intelligence, but the price is about a quarter of what it was just 5 years ago. So all of those factors that we've talked about so far, the wafer level packaging, the smaller pixel pitch, etc., fueled by that market growth, has really enabled us to deliver a price point which is much lower and therefore much more cost effective for the general CCTV type of applications. One of the other trends has been very much a move towards higher and higher resolution. When I first started selling thermal imaging, I don't know, maybe 10 years ago now, then it was very much, you know, there were 2 resolutions in thermal, and it was 384 by 288 or 640 by 480. That was it. You had low res, you had high res. And when you think of 640 by 480 as being high resolution, then you know that you can see how far things have gone on now when we're able to supply and easily detectors with 1280 by 1024 resolution. So you can see how far that change has come back in you know, from just maybe 10 years ago. And of course that's enabling us to produce a much more detailed picture, but also to see further. So you know, one of the big advantages of a thermal camera is its ability to see very, very long distances, and in some cases up to 20 kilometers to be able to detect a motion at 20 kilometers. And if you think of an application, one of the ideal applications for thermal technology is perimeter protection. If you think how many cameras you'd need to protect a border or a perimeter at 20 kilometers long, and you can do the same thing with one thermal camera. So yeah, maybe the camera cost is a little bit higher, but in essence, you can do a lot more. It's one camera to install, one set of cabling, one set of power requirements, and only one set of data to record. So whilst the product price itself may be higher, you can achieve a lot more with one camera. So please remember that. So in summary, really, if we have a look at the thermal market, we know because we know from market research, we've got the potential for good market growth. We know the cameras are reducing in price because of the wafer level technology and the smaller pixel pitch. And we've got at the same time higher and higher resolutions, and we're adding, as you'll see later in the webinar, in the next section, we're adding more and more features. All of those factors added together make thermal camera technology an excellent sales opportunity. So if you're not currently using thermal, give it a go. Try one of our cameras. Talk to one of our value-added distribution partners, and we'll share a list of those at the end of the webinar. Get in contact with them, arrange a demo, just have a look at it, see what you think. It doesn't cost you anything to arrange a demo, it's completely free, and I think you'll be impressed and surprised at some of the results, especially when you balance what you can get compared to the price this technology is costing these days. It's gone from very unaffordable to very, very affordable. Okay, so let's have a look now. We've had a look at a bit of insight in the market. Let's have a look at the solution introduction. And there are four areas that I really want to talk to you about in this section, and they are in priority really. So the most common type of application for thermal cameras is perimeter protection, and we touched on that a little bit earlier. But we'll come on to that in some detail in a few moments. But also fire prevention. Those two are the most popular type of application for thermal cameras. But there's also, as we saw from the market research, some other big growth areas. One of them is industrial temperature monitoring, and the other is long distance monitoring. So if you're looking maybe to protect a coastline, so you've got very large distances that you're trying to monitor and protect, then long distance monitoring can really be good. But they are a different breed of camera altogether, as you'll see. So let's start by having a look at the first two. But before we go into perimeter protection, I just want to just to make something clear. There are three, as we saw. When we look at the electromagnetic spectrum, there are some very clear areas. There's the X-ray part, there's the visible light part, and there's the thermal part as well. These are three separate applications. Okay, so a thermal camera, despite what a lot of people think, a thermal camera is not an X-ray camera. It cannot see. It's not Superman. It doesn't have X-ray vision. It can't see through objects. It has to be able to see someone to produce a thermal image of that person. So if you're looking at a monitoring solution, maybe you're trying to find a person in a forest. If that person is hiding behind a tree, the thermal camera will not see that person because they're hiding behind a tree. But if they're just in the leaves and the branches, in the foliage, there's a good chance the thermal camera will detect that person, whereas a visible camera will not. So at the moment, we don't have X-ray cameras. Okay, so please remember that there are limitations to thermal technology, but there's also a lot of advantages as well. So let's go and have a look at the perimeter protection solution in a little bit more detail. So to start with, let's take a look, as we often do, at the solution values. Well, to start with, we call it low light. In fact, that's a mistake on the slide. It should say no light. You do not need any light to produce an image on a thermal camera. It doesn't improve it. It doesn't make it better. It doesn't make it worse. It just doesn't need it. Because if you remember, when we looked at the electromagnetic spectrum, it's looking at a completely different part of the spectrum. It doesn't need it. Light can't pass through a germanium lens, and therefore it's irrelevant. So a thermal camera allows us to produce an image totally irrespective of light. Okay, so there is no need for that. And therefore 24/7 monitoring is good. We don't need any additional lighting. So as often happens in CCTV type applications, sometimes you need to add infrared or white lighting to an application in order for a subject to be seen. If you use a thermal camera, you don't need any lighting. You don't need IR. You don't need any white light. You don't need any ambient light, because the thermal camera is looking at thermal energy, not visible energy. It's also a lot less affected, if you like, by weather. So rain, mist, fog, etc. The camera can to a large degree see through a lot of these harsh environments. When you compare that to a conventional camera, a visible camera, it makes it very hard to see, for example, in fog, as you'll see in a few slides' time. And because it's not using visible light, it's a lot less affected by false alarms. So we're able to achieve a very low false alarm rate. So again, because we're looking at thermal energy. So if you think about one of the most common causes of false alarms in an outdoor application would be trees moving or leaves blowing in the wind. They have no thermal mass, and therefore they're not going to trigger motion detection on a thermal camera, whereas potentially they may trigger that on some of our competitors' brands of motion detection, not Dahua, of course. And also we're able to achieve dual spectrum monitoring. So this, if you like, is the fusion of a visible camera and a thermal camera in the same package, and we're able to merge these two images together. And you'll see some pictures of that in just a moment. But at the same time, we're able to do everything I've mentioned. We're also able to achieve an active deterrent. So if motion is detected, we can replay an audio file. We can have communication from the camera to the through a loudspeaker, or also maybe we can flash a light. We can turn a white light on, etc. So having that ability to communicate from the control room through the camera to site to the camera location, or indeed have it automatic. The ability to provide that active deterrent is very key. So let's have a look at some of these points. So low light surveillance. Okay, let's take a look at that. So we know, as we said, conventional cameras need light, thermal cameras don't need light, and therefore we can reduce the amount of light pollution. So if you were trying to use a camera in maybe a residential area where there are light restrictions, a thermal camera, those things don't apply because there is no light pollution. So that enables true 24/7 monitoring, as you would expect. So if you have a look at the two images over on the bottom left-hand side, we've got the view from a conventional camera, and then to the right-hand side, you can see that actually the camera's looking at there is a ship there, a cargo ship. So this is a port type application, whereas the camera is you think there's nothing there, but when you because it's at night, the camera can't see it. It's impossible to light something that far away, but a thermal camera can easily see and detect what the subject is in the distance. So a really good example of the benefits of a thermal camera compared to a conventional camera. And if you look at the two images on the right-hand side, again, there's a person hiding in the foliage. Again, they're not hiding behind a tree because a thermal camera wouldn't be able to see that. But the view from a conventional camera, if you were a security guard looking at that screen, you would not see a person hiding in the bushes. Whereas a thermal camera, because they're not completely concealed or obstructed, then it is possible that the person can see, the subject can be seen, the target object can be seen with a thermal camera. And again, that can be used to trigger motion detection. So really improving security. If you were relying on this application for motion detection with a conventional camera, it would not be triggered. Whereas with a thermal camera, it could be triggered. Let's look at the weather scenario. So again, all weather surveillance. Conventional camera on the left-hand side. You can see it's a foggy, misty day. You can't see the two people that are in the distance. Whereas with the thermal camera, it can clearly see them because it's able to look through. It's looking for thermal energy. Now, again, I'm not saying that a thermal camera can see through all weather conditions, because obviously fog or mist is a collection of rain droplets, and thermal energy doesn't pass through easily through fog or rain. But in light fog, light mist, light haze, as per the picture on the left-hand side, the thermal camera can clearly see that there's a couple of people walking. And again, if that was to be the perimeter of an estate, then motion detection is completely possible and easy for the camera to detect motion in that scenario. It's also the system is highly accurate. And because it's using thermal energy to do the detection, it doesn't rely on traditional motion detection. And Dahua is leading the way in terms of our smart motion detection 2.0. So we already have on visible cameras, we have a highly intelligent motion detection solution that reduces false alarms. But we've taken that technology now and we've applied it also to thermal. But as I mentioned, one of the most common sources of environmental motion is leaves and trees moving in the breeze. They don't have a thermal mass, therefore they're unlikely well, they won't trigger. We're using a thermal camera, whereas there is a possibility on some brands of camera that they would trigger using a visible camera. So thermal cameras have a great advantage there. And again, we do that through AI-based learning algorithms. We can also detect the difference between people and vehicles. So if you're searching through a recording, through recorded data from a thermal camera, you can ask it, just like you can on some of our visible cameras, you can say, okay, I'm only looking for a particular vehicle, and you can apply that search to just the vehicles and ignore the people in the recording. And then also the dual spectrum monitoring. So the dual spectrum monitoring is the combination of a thermal camera and a visible camera in the same form factor. Okay, so bringing these two together, overlaying, if you like, the thermal the thermal image over the top of the visible camera. So not only can you see what's going on, but you can also monitor the temperature as well. So the fusion mode makes it very easy to see the benefits of both, because both details are being recorded. They can be recorded separately or individually as one stream or multiple streams from the same camera. And finally, let's not forget the active deterrent. The active deterrent, the motion detection has been triggered. It's detected motion in this example, so it can turn on, it can play a pre-recorded audio file, or it can flash the white light to indicate that a person has been detected. So having that active deterrent is a really important benefit to the camera, and again, something we feature on many of our cameras, as you'll see later when we come to look at the analog over HD. But this active awareness, pushing that information out, putting the intelligence in the camera nearer the edge, nearer the events, and hopefully preventing incidents from occurring. So finally, let's before we move on to the next section, let's just take a look at some of the applications. Let's just take a look at the range. As far as perimeter protection, we make an entire range of products, as you would expect, all the way down from cameras down here at the bottom, which are sort of sub 100 meter perimeter protection range. And again, the price reflects that, and it goes all the way up to the top, as you can see, which is up here at sort of 10 to 20 kilometers. But again, look at the size of the camera, and we'll come on to look at that in a little bit more detail, in the webinar. But down here, down at the bottom, is where we really want to focus our attention. So I'd like just to quickly introduce to you the new 1 series, the new 1 series cameras. Okay, so these are very compact. So they come in either a turret style or a bullet style. The 1 series is a great choice for end users who really want to take advantage of both thermal and visible in that fusion mode. You can use them separately or independently. It's entirely up to you. But it is a simple one-stop shop, and not only does it have thermal and visible cameras, but also a lot of the AI functions that we talked about, like smart search, like the motion detection, etc. All of that is included in this 1 series of cameras. And I think, as I said, if you're interested in this camera, then please talk to your Dahua representative or one of our value-added distribution partners, and get some pricing. But more importantly, because the world looks great in a PowerPoint presentation on a webinar, but have a look for yourself. Try it in your application. It doesn't cost anything to try the product. So please, we've got plenty of demo stock. Our distribution partners have plenty of demo stock, and if they don't, we'll provide it. Just have a look at the camera, see what you think. Doesn't cost anything to try it. So let's have a look at before we look at the perimeter protection in general. Let's look at a success case that we had. This is a European airport, but if you have a look at the number of cameras looking just around the airport, I think it's like 7 cameras looking around here, protecting the entire outer perimeter of this airport. And when you think of how many cameras that would have taken, had you been using traditional CCTV surveillance, visible light, conventional cameras, it would have taken dozens and dozens of cameras. That's a lot of installation costs. It's a lot of cabling. It's a lot of infrastructure. It's a lot of data to store. Whereas with 7 thermal cameras working over hundreds of meters each, you can achieve the same job. So maybe the product cost is a little bit higher, but installation cost and all of the infrastructure cost is a lot less. And you achieve a very, very high level of accuracy at the same time. Okay, let's have a look at the second scenario, the fire detection solution. This is, we call it fire detection, but it doesn't have to be a fire. It can be, but it could, more importantly, it's about early detection of a potential fire. So the current challenge is both indoor and outdoor. Let's take a look at them. Sometimes it could be outdoor, but you often have like a distribution, a power distribution area within a building, a plant room, where all of the electrical systems come back to, and there's a lot of power distribution, maybe UPSs, etc., especially in applications like data centers, etc. So equipment rooms, substations, often high sources of heat. So a thermal camera can really give you early detection and early warning more rapidly than traditional conventional technology, as you'll see in a moment. But being able to provide that early detection is really key. And also, a lot of customers use thermal cameras now in waste recycling plants. This is big business. So there's a lot of, as we quite rightly try to recycle more and more of our waste. But we can, example would be things like biodegradable waste, like garden waste, grass clippings, cuttings, etc. All of that substance, they're all piled up at waste recycling plants. Because it's biodegradable, it's generating heat, and there is a huge premium having to be paid by recycling companies because of a risk of fire, and they have to invest very heavily in that. A thermal camera can monitor a pile of waste, and if the temperature exceeds a certain value, it can trigger an alarm. So it's a really good example of an ideal application for thermal camera technology. And again, if we look towards outdoor, whether it be monitoring forest fires or trying to prevent forest fires, overlooking scenic areas, or indeed if you're a farmer and you're trying to protect your farmland, the ability of the camera to look over these wide areas and detect the outbreak of a fire is really important. And again, it's about prevention being better than cure. So providing that early detection and that early alert to the operator that there may be a fire is really key. So let's build on that and have a look at some of the solution values. Well, we talked a little bit about early warning, but not only is it provide you with an early warning, but also it's highly accurate. So we know we can detect fire with a very high accuracy of a false alarm rate of less than 5%. Also, we can detect an alarm to dangerous behavior. So if you're smoking, maybe if a person's smoking in a petrol station, or they're using a mobile phone in an explosive environment, we can detect and alert to that eventuality. Again, just as we did on perimeter protection and the standard thermal cameras, we have dual spectral monitoring. And also real-time alarm. So if a fire is detected, we can provide an immediate alarm. So let's take a look at those in a little bit more detail. So firstly, early warning. A thermal camera can detect, because it has an AI-based algorithm inside it, it's able to detect a fire at its very early stages. So again, if you rely on traditional technology like a smoke detection system, or a heat detection system, it relies on there being quite a large thermal mass in order to be able to generate enough smoke to trigger a smoke detector or to trip a heat detector. The fire has to have quite a big mass, whereas the AI algorithm inside, it knows what the shape of the flames are, and what a flickering fire looks like, compared to, say, another heat source, perhaps like a cup of coffee, but or another hot drink. But you can have, so that the ability of the camera to be able to detect that pattern of fire and provide that early warning that there is a potential danger is something that we can do a lot more efficiently than smoke detection or conventional cameras. As I said, it is also highly accurate in the sense that it can detect at distance. It knows the shape of flames, as compared to, say, a hot drink, or like I mentioned earlier. Also, smoke detection, being able to detect if a person is smoking in a potentially explosive environment, which will reduce danger. You can create an alarm if the camera detects a person is smoking, then it can present an alarm and to alert the person. And also in the use of mobile phones in restricted areas like petrol station. So, you know, we all know you shouldn't do it, but a thermal camera can give you early alert and early detection if somebody is doing it. So not only is it using thermal technology, but it's combining the artificial intelligence features, those deep learning AI-based algorithms, in order to provide these additional features that perhaps wouldn't have been possible 5 years ago. And we already touched on dual spectrum monitoring many times, but here's a picture of it now for you. So here's the combination in the same form factor of a visible camera and a thermal camera. And there are various different detection zones depending upon the type of lens that you select. And we make a range of lenses depending upon your individual application. And finally, before we look at the range, the real-time alarms. It's important that we're able to generate real-time alarms. So if a person is smoking, if there is a fire, if motion is detected, you want to be able to have that alarm delivered through the camera to site, either by flashing the white light or maybe playing an audio file or having communication from the control room directly through to the site through the speaker. You want to be able to have that as quickly as possible. So being able to detect and react and respond as quickly as possible is really key to and is one of the key benefits of thermal technology. Okay, so in terms of fire detection, we can do it as you would expect on an entire range of cameras, depending upon your application. So again, some of these cameras can also be used, of course, for perimeter protection, especially the ones over here. But if it's indoor, indoor and outdoor, depends on your particular application. It's entirely up to you. So it's all about choosing the right product for the right application. But whatever the application is, Dahua has a product and a solution to help you. Okay, let's have a look at the industrial temperature monitoring. Now, we've looked at lots and lots of different solution values. So when we come to look at industrial temperature monitoring, I don't want to go through the solution values again, because actually they're the same as the heat and the perimeter and the motion that we've been talking about so far. So remember those solution values, they apply equally to industrial and long-range detection, as you'll see later. But I did just want to share with you some images of industrial type monitoring. So again, I've got some good examples here of mainly of power plants, because this is a very common application for thermal technology. Again, you can see top left-hand side, this is a transformer array, and you can see based on the color, if you like, produced by the thermal camera, white is hotter than red, and is hotter than purple in this application. So you can see that at the top of this transformer array, where the heat is rising inside with the oil, the coolant being circulated through the transformer, this is the hot spot. And again, if you look at the bottom left-hand side, again, you can see these conductors. Again, you can see where the heat points are, and actually we're able to produce temperature monitoring. Solar panels, you can see, you can begin to see if a solar panel has started to become defective in some way because it's generating itself more heat. Maybe there's some reason for that, but it can be investigated. So again, routine maintenance is a very large application for thermal technology. And again, looking at this large array in the top right-hand side, we're able to monitor the temperature. We're able to select and draw using the setup software in DSS Pro. We're able to draw different zones and measure and monitor the temperature and alert if any of those zones go above a predefined level. So giving the operator early warning, giving the early warning of potential application, sorry, a potential incident that may occur in the plant. And if you're running, a power plant for a city or a town, it's really important that you're able to do that. So having the ability to monitor is really key. But that's something we'll come on to in a few moments. And finally, bottom right-hand side, this is just a standard, a three-phase fuse array. I wouldn't want to get anywhere near this, but you can see that one of the phases in this diagram, sorry, in this image, one of the phases in the middle is actually getting hotter than the other two. So again, there could be a reason for that. It could be that more people are in the office than they're connected to that phase, but it could be an indication that one of the connectors is loose because they should be load balanced. Maybe there's the bolts on the connector, and some of them sort of are as big as your head in large industrial applications. So it may be some routine maintenance is needed to inspect this. So again, thermal cameras giving early warning, early detection of potential incidents. Again, I don't want to spend a lot of time on this for the reasons that I mentioned, but being highly accurate, generating real-time alarms, unmanned inspection. If you're running a power plant, if you're using one of the applications that we looked at just now in the previous slide, unmanned inspections, having a PTZ camera that you can move around, you can look at individual parts of the power plant, of the power distribution system, really makes it a lot easier. You can do it automatically. You don't need to send people into hazardous situations. So again, really great applications for thermal camera technology. And again, giving you a lot of opportunity to sell these solutions into customers, into potentially new markets. And in terms of that application just alone, this is our software, our video management system, DSS Pro. And again, you can see we've got, in this situation, we've got a PTZ camera. We're able to look at the live view. We're able to look at temperature alarms. We're able to look at the thermal image. You can do various analysis tools if you want to look back over historic temperatures in particular zones. You can look at temperature distribution across different times of the day, the night, the week, the month, etc. So you can begin to get a lot of analytics from this in the industrial world. And finally, before we move on to look at the long range, the list of products. So again, we've put this there for your reference. We'll circulate these slides afterwards. So again, all the way through to the PTZ product over here, the hybrid type products, all the way down to the individual handheld series of products that could be used for routine maintenance type applications. So finally, long distance monitoring. Again, all weather surveillance, we talked about that. Long range monitoring, target distance detection, so you can use thermal and a combination of thermal and laser to do that. We have extra sensitivity sensors, and of course the AI features as well. So in terms of long range monitoring, again, in the thermal world, there's something called the DRI calculation, which is detection, recognition, and identification. Detection is there something there? Is there motion, if you like? Recognition, is it a boat or is it a motor vehicle? And identification, is it friend or foe? So that DRI calculation, the three parameters of that make it really important. And in this application, as you can see in the top set of pictures, we're able to detect up to 20 kilometers with this particular lens combination. That's detection. Up to 20 kilometers of detection, and then recognition up to 7, because it's a lot easier to detect something. You can detect something moving a lot further away than being able to know necessarily what it is. But we know we can recognize using this lens, we can recognize that it's a boat, and that's at a 7 kilometer distance. And then the bottom one again is the same thing, a different lens. This is at 11.8 kilometers. So when you think from where you are, you can see the bottom left-hand image. You can start to see where the camera's pointing or where the boat is. And when you zoom in with the lens, you're able to see clearly, that recognize clearly that it's that it's a boat at such a large distance. And then the HD sensors. So again, as I said in the introduction, moving more and more towards higher and higher resolutions, higher sensitivity sensors. We talk about the NETD. So in visible camera, conventional camera terms, we talk about the sensitivity of the camera, and that's often presented in lux or lumens. In the thermal world, we call it NETD, which is net equivalent temperature differential. It's the thermal sensitivity. And again, as resolution improves, so does sensitivity. So we're able to detect 25 millikelvin. So a very small change in temperature is able to trigger and be detected by the camera. So let's have a look at some of those cameras. Again, remember, this is for long range detection now. You're not going to find one of these, you know, on a house in a city center, town center type application. But these are for very, very long range detection. So you can detect using all different types of zoom lenses. They come with laser rangefinders, digital magnetic compasses for GPS, etc. So we can know exactly where the camera's pointing and give coordinates, etc. But all the way up to 900 millimeter lenses, huge lenses capable of looking over very, very wide areas. Okay, so that was a look at thermal technology. So just to wrap up now, let's take a look at HD CVI. HD CVI is, of course, an acronym. Stands for High Definition across a composite video interface. In other words, it's high definition across a piece of coax cable. That's the easy way to remember it. And as I said in the introduction, if you have a customer that's got a lot of cable, a lot of RG59, RG60 cable in their building, they don't have to take it out. Of course, it can be beneficial in some instances to do that. But if they have such a large investment, or they have a camera that's maybe 2 or 3 kilometers, maybe 1 or 2 kilometers away in a remote site, and the only thing there is a piece of coax, you can utilize that coax. You can put a camera at the end of that and bring it back into the control room. So there are 2 areas that I'd like to talk about here. HD CVI, a TIOC version. Some of you would have attended the webinar and be a range of our TIOC range of cameras. Really rapidly becoming, I think, has become our fastest and best-selling, one of our best-selling cameras. So having that TIOC technology now, originally it was in the guise of in the reserve of the IP range. Now it's available there's an analog version of that as well. And additionally, at the end, we'll talk about a 16:9 5 megapixel version of the HD CVI camera. So some of you will be familiar with some of the features and the solution values of the TIOC camera. So we talk about full color, we talk about active deterrent, and we talk about artificial intelligence. Those are the 3 cornerstones, if you like, that make up and have been so popular with TIOC. And as I said, in the past that's been reserved to IP, but now it's been brought up to date and included as part of our HD CVI range. So all of those TIOC benefits are now available in an analog version. So of course, it is a 3-in-1 solution. Okay, you have the benefits of artificial intelligence, you have the benefits of full color, you have all of the things that we talked about earlier. We have full color monitoring 24/7, so the ability to give a good quality picture even at night. Also active deterrent. We have the ability to, just like we did with thermal when we looked at being able to flash a light, we can warn off intruders using LEDs, flashing LEDs, or an audio file, playing an audio file. Also deep learning based XVR. If it's connected to an XVR, we can begin to learn the motion patterns, etc., and really improve the target efficiency search. So if you're looking for just people movement within the scene, you're able to achieve that. And finally, AI coding. So using H.265 coding algorithms, which is about 90% more efficient than H.264. So again, I don't want to go into these in large amounts of detail because we have covered these before when we looked at the TIOC. And again, go if you go to the website, and we can send you a link to this later in the day. You can see review the webinar that we presented on TIOC. But some of the technology that goes behind producing that full color image is large aperture lens. So an f1.2 lens, which allows 1.8 times more light to enter the camera compared to an f1.6 lens. The high performance sensor, the advanced signal processor, both self-developed technologies based on our research and development laboratories, and also that warm light capability. But what does that warm light mean in an actual application? So if we have a look at a couple of these sample images, the image on the left-hand side is with the warm LEDs off, and if you look at the image on the right-hand side, the warm LEDs have come on. So once the light level has dropped, it gets to a trigger point, and then the warm LEDs come on, and they provide scene illumination. So you can clearly see that there are some areas in the bushes behind the car, or actually, did you notice that there's a ladder in the foreground? So if you were trying to monitor that without the warm LEDs on, it would be very difficult to see if anybody was there, or that there was any potential danger in those areas. The warm LEDs enable you to see that additional information. If we look at a graph of the light level compared to time, as you'll see, exactly as I was saying earlier on, the camera is in the starlight mode, and it remains in full color for as long as it possibly can. But when it gets to approximately 2 lux, the warm LEDs come on and return to the sort of image that you saw on the previous slide. So really enhancing the image that the operator is seeing, or the customer is recording. So that's full color monitoring. Let's have a look at active deterrent. So I touched on these many times, so probably not worth going over these in too much detail. But it doesn't matter whether you have active deterrent with the red and blue flashing lights, or whether you use the speaker for two-way audio communication, or indeed whether you use the perimeter protection for motion detection. It is all built in. Okay. And then finally, the artificial intelligence. So this is the ability to search whether you are looking for a person or a particular object, maybe like a vehicle or a non-motor vehicle, etc. So the ability to in your search pattern to be able to detect person or vehicle, which reduces, if you look at that blue bar of recorded data, there's a huge amount of data there. By using the intelligent search application, we're able to really reduce it down to a lot more manageable information. So there's a lot less information for the operator to search through. Again, all of that capability and all of that technology is when the camera is combined with our XVR. And in terms of the TIOC solution topology, again, this is there for your reference. I don't need to cover this today, but as always, we like to give you some idea about how the system connects together. So again, you've got those cameras connected across coax to the NVR, to the XVR, AI XVR. And again, that can be monitored either using our central management software DSS Pro or our DMSS mobile solution. So finally, in the last few minutes of the webinar, before you get to play the quiz and win a prize, let's just quickly talk about HD CVI 16:9. So just to really give you a little bit of background, traditionally, almost 99% of the images used in the industry, not just with Dahua, in the industry, have been of an aspect ratio of 4:3. And what manufacturers have done is to stretch that image slightly to be able to fill a widescreen monitor. So what we're able to do is to utilize Starlight technology, the deep learning algorithms that we've been talking about, the AI coding, the 16:9 aspect ratio, and a larger field of view. These are all combined together to give you a much better image. So if we look at a lot of that technology in terms of an actual application, previously, as you can see on the left-hand image, we would have stretched that image a little bit, which has tended to distort a little bit of the image. But now we're moving towards the true 16:9 native imager. Then we're able to really show the image in its truest sense of the word. But as we looked at in the solutions values, not only is it about aspect ratio, but it's also about the ability to produce a good image as well. So what we find with the 16:9 imager is it's able to stay in full color mode for longer. Okay, so again, not only is it providing 5 megapixel resolution, native 16:9 format, but also staying in color for a lot longer. And then finally, really, before we look at the product list, the greater field of view. It is because it is true 16:9, you actually get a little bit of additional information at either side. So the field of view is expanded to 111 degrees. And then, therefore, as we've done with everything else, there's a list of products. So again, don't expect you to remember it. You don't need it for the quiz, but you will on the next slide. Start the quiz. So please, as I said, don't hesitate to have a look at these. Talk to our representatives and arrange a demo. Okay, as a reminder, in just a moment, you're going to have the quiz. You'll need that information, and I'll put it up on the last slide. So if you haven't downloaded Kahoot, please do so. In terms of where to buy Dahua, if you're one of our customers and you're not familiar with one of our value-added distribution partners, then here's a list of those distribution partners in the UK and Ireland. So I'd really recommend, as I said, if you have a demonstration, if you require any additional information, please reach out to your local Dahua representative or indeed one of our distribution partners. Okay, so thank you once again for attending this webinar. It's been great to present this latest technology to you. We're really excited about it at Dahua. But we've seen a lot of the images. Hopefully you'll try and try many of these yourself and arrange a demo and have a look, and then come back to us and let us know what you think. If you don't like it, come back to us and tell us why, and we'll improve, and we'll try and find answers to your solutions. So I'm going to go back now to the previous slide, the commercial quiz. So if you'd like to download that, you're welcome to. As I said, you can win a hamper. The quiz is open until 12 o'clock. So open for the next hour and 2 minutes. So please don't hesitate to do that. So thank you once again for joining the webinar. We look forward to talking to you on the next one next month. In the meantime, have a good day, stay safe, and good luck with the quiz. Thank you.